So this brings up two important concepts that we will talk about in this video: matter and energy. Right? So matter is the stuff and energy is the light. And we'll find that that's really the heart of chemistry, is what is matter and energy and how do they interact with each other. So first, let's talk a little bit about matter. So we could use a general substance, matter, stuff. That's our everyday language, but in science we like more precise definitions, so we'll use anything that has mass and takes up space, which sounds like a lot of stuff. For example, air, water, people, viruses, all of those are matter, right? They contain mass and take up some space. We can think about that matter on three levels: the macroscopic, the microscopic, and the symbolic. So the macroscopic we can think about is what we can see with our eyes, right? What we can see. Microscopic is the arrangement of atoms and molecules. And symbolic are chemical and mathematical symbols that help us figure out and display what's going on. So we'll say chemical and mathematical. So as an example to illustrate this, let's look at this picture of diamond from the textbook. So we've got the macroscopic picture of our big diamond, sparkling. And then we have the microscopic picture of how the atoms are actually arranged in diamond. And we see that we have, for each carbon, it is tetrahedrally connected to 4 other carbons. And we use the symbol capital C for carbon. We also use the same symbol for all the different forms of carbon, of which there are many. One that you're familiar with is graphite, because it's what's in your lead pencils. So that looks a lot different than diamond, right? It's gray, it comes off on paper easily. It has a very different molecular arrangement. It's more arranged like this, where the atoms of carbon are in patterns of hexagonal circles. So that different microscopic view lends to a very different macroscopic picture. And we can see how those are all interconnected. Further, we can think about the properties of matter. For example, chemical and physical properties. So we noted with the diamond, they looked very different. They're physically very different. Diamond, even if you rub it on paper, is not going to come off the way a pencil lead does, or the graphite in your pencil. They also behave very different chemically. We can also talk about intensive and extensive properties or variables. Extensive depend on the amount, the extent of material, things like mass, volume. Intensive do not depend on the amount or the extent of material, things like temperature, density, color. Those are all intensive properties. Further, when we're thinking about matter, we can think about the 3 main states of matter: solids, liquids, and gases. So here we have an example of some pictures of water from your textbook. So water, symbolically, H2O, right, means there's 1 oxygen for every 2 hydrogens. We can see that illustrated most easily in the gas phase molecules, where we have 2 little white balls to represent the hydrogen and 1 red ball to represent the oxygen. So note that, so we've got this fog over the lake, and we see that in the gas phase, the water molecules themselves are far apart. They are also moving quickly, so these are little zoom lines here. So that is what distinguishes that state of being a gas. For liquid, we see the molecules are much closer together. They are also still moving can't see this in the picture, but if you were watching them, you would see that they are moving. And we see that the liquid in the lake is a liquid. In the winter, when it freezes, the lake freezes over, or there's snow, we have solid water, and we see there's a different packing pattern for the water. It is not moving much, and there is a specific arrangement of atoms in the solid phase. So that's our quick run through of matter and thinking about how we describe matter. The other thing we talked about was energy. So what is energy? Energy is a measure of the capacity to do work. So we're thinking about how energy, in a practical way, how we can define energy. And let's talk about 3 important forms of energy: kinetic energy, potential energy, and electromagnetic energy. So kinetic energy is the energy something has because it's moving. So kinetic energy is dependent on the mass of the thing and the velocity squared. Potential energy is the energy something has because of its position in a field of force. So we live on a planet that has gravity, so we can think of that gravitational force field, and we can measure the mass, the gravitational constant, and h, the height. So however high we are above the Earth, that changes the amount of potential energy something has in that gravitational field. We can also think about potential energy in an electronic force field, where potential energy is proportional to the charges of our 2 particles, Q1 and Q2, and R, the distance between them, also gives rise to potential energy. Electromagnetic energy is another name for light energy, and that energy is equal to Planck's constant h times nu, the frequency of the light. We'll talk more about that later. We can also think about the total energy of our system, and we can talk briefly about the law of conservation of energy, that the total energy is conserved. That is, energy total is equal to kinetic energy plus potential energy. That is, we can't create or destroy energy, we can just turn it from one kind of energy into another kind of energy. So this interplay between energy and matter is something we will build on throughout this semester, next semester, and throughout your study of chemistry, since energy and matter are at the heart of chemistry.